Once you successfully log into the platform, you will be redirected to the home page where you can see the list of projects on which the tests have been executed. Here, let's have a look at the Finance QA project where it's a experiment being executed on a financial dataset over a question and answer chatbot in order to assist you with your financial queries. So inside the project, the user can see the list of experiments which have been executed on different datasets inside the project, and the list of datasets which have been uploaded in order to execute different experiments can be viewed inside the dataset tab. As you can see, here are two datasets of which have been run on GPT model and one on the Llama model, and the complete execution of both the logs of the dataset can be viewed inside the logs tab, where you can see the schema of your dataset and also a deep dive into the complete dataset, including the prompt responses and different metadata included. In order to view the insights of your experiment, you can click on view result on any of the experiment to open the results tab. Here you can see all the artifacts on which the experiment has been executed, including the dataset and the different kinds of metrics. And in the metric summary table, you can see the metrics being categorized into different sections and the configuration of each of the metric. Here you can see that the context relevance of this particular model is really high, which means that your RAG mechanism is working perfectly. Whereas there is a severe amount of hallucination which has been detected in some of the points, which is a concern for the user. To drill down deeper into the metric which is causing a disturbance, which is hallucination, you can look at the metric distribution graph as well, where you can see that out of the 114 data points inside this data set, there are 49 data points which are causing an issue and hallucination. In order to see which particular prompts and were causing these issues, user can look at the data points table and sort the value of hallucination. So as the user can see that there are all these prompts which are causing hallucination, and there are also some which are causing context relevancy issues. So in order to drill down deeper into both of these metrics, user can click on the prompt button, which will open the data point view where they can have a detailed analysis over the prompt, the response, the context, and other different metadata and attributes involved in the particular data set. As you can see that the hallucination detected here is 1, and in the reasoning section you can look at the reason which is causing this. It is because that the information here is not supported by the context which has been retrieved, and hence the final response is inaccurate. In case you have uploaded your dataset alongside with traces, you can click on the trace view tab and look at the complete instrumentation of your application using our trace details. We log the individual steps of the execution which have come in different types, such as event spans and all the final generations which have been retrieved. Now in order to compare this particular experiment which has been run on the Llama model against the different pipelines in your project, we can go into the experiments tab, and as you can see we have two experiments, one on the Llama model and another on the GPT model. In order to compare your Llama model against your GPT model, you can click on select here to compare, select both of these experiments and click on the compare view. It will redirect you to our comparison view where you can analyze both of these experiments side by side. As you can see that the hallucination values of both of these models are quite similar, but there are scenarios in which, as you can see, that the Llama model has detected quite a few data points which has PII indicated, but the case of GPT, the score is quite low, and also that the contextual relevance of the Llama model is higher than that of the GPT model. This helps you create clear conclusions of your experiment. Looking at the metric distribution of the contextual relevance table gives the user a clear idea that the Llama model has a higher contextual relevance as compared to that of the GPT model. In order to select a baseline model against which you would want to compare all other experiments, user can select a baseline model from here and compare the responses of different models over the same prompts and look at how the metrics are working on it. So as one can see here that the GPT model is not retrieving the relevant context, whereas the Llama model here is retrieving the right context. So for the Llama model, one can easily see that for the prompt asking for the weighted average one can easily see for the prompt asking for the growth rate in 2010, the response here is grounded to the context which has been retrieved, and the reasoning of which can be easily validated from the reasoning tab, that the context which has been retrieved has the specific information of the average weighted values for all the years, and that's why the calculation here is accurate. Whereas for the GPT model, one can see that the contextual relevance for the same prompt is zero, and the response of which is also quite different from the context it has been retrieved. The reasoning of which can be validated from here, that the context which has been retrieved does not have the accurate context of the following years, and hence the response is not grounded to the contextual relevance. This is how RagaAI Catalyst would help you identify the issues in real time and identify them seamlessly in order to deploy your LLM applications in production faster.